morning, good afternoon, good evening. Welcome
Hi.
to this new episode of the Water Talks podcast. I'm your host, Els Vanbeckevoort, and I'm delighted to be joined with my co-host, Scott Bowron. Hi, Scott. Good morning.
Good morning, Els. It's so good to see you. And you can see in the background the sun is shining. It feels great.
It does. It does. We like that here. A little bit of sunshine in the winter, that's for
Oh,
sure. Yeah. So,
awesome. Uh, we're starting off today, and before we start, I wanted to remind you, if you haven't heard for January's podcast, tune in. It was recorded in Belgium at Labo Durva, and take a listen to learn about best practices about cleaning in and around the pool and the pool deck. It's an excellent thought. Today, though, we are excited to progress our conversation on pool process automation with a unique focus on pool pumps. And a big welcome to our guest, excuse me, Gerben Upton Buijs. Welcome, Gerben.
Thank you, Scott. Good
hey.
afternoon.
Good afternoon.
Hey, good
Sorry,
afternoon. Yeah,
here in Holland we don't have sunshine, we have rain today.
sorry to hear that. That's too bad, but it's great to see you again. For our
Thank you.
listeners, Gerben is an electrical mechanical engineer, and he's also the CEO at SEM Water Treatment in the Netherlands. He's an esteemed colleague, and he has much practical experience in pool monitoring with pumps, control systems, integration, and automation. We've been blessed to have Gerben visit us frequently here in Canada, and we're delighted that he's able to spend a little bit of his time with us before he's going on a well-deserved vacation, I believe, later. So nice to see you today, Gerben.
Thank you.
Yeah.
Hey, Gerben, I wonder if you could start us off just for those who would know you, which is a new name here in Canada. Tell us a little bit about yourself. Let's say your education, years in pools, just a little bit of background to
Yeah.
get it rolling.
So my name is Gerben Buijs, and I'm the general manager of SEM Water Treatment. Well, I'm 48 years old, and I'm related to pools already a very long time because I started to swim as a small boy in the pool by me in the place where I live. And we had a 25-meter pool over there. It was built in '84, and I started swimming there, and I got all my examinations there. And when I was 14, 15 years old, I started there as a student job for helping to clean the pools, to clean the bottom. So I went down with my goggles and jumped in the pool and cleaned the bottom. And later, I was with my nose in the technical room of the swimming pool. One of my hobbies was, playing around with electronics. And then the owner of the pool, he showed me all the technical stuff in the pool, so the filter pump, and he was working with dosing pumps as well. He was trying to build some new pumps, but he didn't have a clue with electronics, so I helped him a little bit with that. And so we created the first proportional dosing pump. So it was a long time ago, and in the meantime, I finished my education. I did university. I started electrical engineering, microelectronics, and since 2000, I started with working at SEM Water Treatment. I did that till the end of 2009, and then I became owner of the company, and since 2009, I'm the general manager, and I still use a lot of my practical and theory to help to develop products and make things better.
Yeah, that's quite a story, Scott. It's like all of us. Somehow we all have a real personal story and connection to pools,
Right.
right? It's not just kind of okay, I've studied it and I'm working in it now, but it's like, okay, I love the water, I love swimming, I don't know,
Yeah.
there's something special
Still
about
swim every week, so
All right. You
Exactly.
live in it. You're
Yeah,
living it.
exactly. So, for those of you that didn't attend our Better Pools conference, Gerben was one of the speakers there as well. And Gerben, your session on different measurement principles and systems, I think, was much appreciated and valuable. We briefly touched, I guess, on what is needed for tight process control in pools, including reliable sensors for monitoring, but also reliable control systems and pumps that manage and optimize processes. So today, I think we're really interested to learn more about the types of pumps, how they can integrate into a control strategy, and how that could support potentially future automation, because that's not necessarily something that's present yet in North America, but certainly there's a lot of interest and excitement about the opportunity that also presents, I guess, downstream as well. So just to get the conversation started, like if you could just share with us your perspective on the big picture, what's necessary for good process control. Like, what would you say are the most important aspects for managing a swimming pool from your point of view?
Well, for a good process control, and what I mean is then controlling the pH value of the pool and controlling the free chlorine level of the pool. The start is to have a good measurement system. So you need an accurate measurement for pH measurement, and you need an accurate system for measuring chlorine. And when
Yeah,
you have a good measurement, you know what the values are, and then you need a good control system. So what's a good control system? A good control system is a system that looks at the water quality. So it looks at the measured values, and after it controls a dosing pump to add more chlorine in the pool, or just a little bit chlorine in the pool, or just make the pH higher or lower by dosing an acid, for example.
yeah,
And the easy way is always a simple way is on off. So when the pH is too high, you switch on the acid pump, and when the chlorine level is too low, you switch on the chlorine pump.
yeah. And
Uh,
we'll get into that a little bit more, I guess, in terms of what makes a good pump and things like that. But perhaps then, if you could give our listeners an overview of, okay, what kind of pumps do we have within the pool envelope? Like, there's dosing pumps, but what are kind of all the pumps, and what are their functions? What do they do? Why they're necessary? And what they are, what are they required to do, I guess, in a
well,
an optimal environment.
in the swimming pools, the heart of the system, the engine of the pool, is your pool pump, of your filter
Okay.
pump. That pump will make the water flow from the pool to your filter equipment, and from the filter equipment back to the pump. So that's the engine of your pool. And without the swimming pool, the filter pump, you don't have a system in your pool, because the water won't flow. So you need that pump to have a circulation.
Yeah.
Because in the pool you have a closed circulation system. So the dirty water is going from the pool to your filter system, and from the filter system it goes back as clean water back to the pool.
Okay.
So
Maybe
you,
Um,
go ahead, Scott.
yeah. So just the terminology you touched on it, Gerben. Normally, that pump we would call the circulation pump or the
yeah,
circ pump or whatever that might
yeah,
be. And I don't know, some of the terminology may be slightly
yeah.
different that you use. Uh, so when you're picking a pump like that, what are some key factors? You're an engineer. You would be telling people this is what I would recommend. That's my assumption of what you do. What was some of the key performance
Well,
ideas that you would relay to the customer?
the most important thing, and a lot of people forget that, is you need a pump that is powerful enough to do a backwash of your filters. Because you can always turn a pump a little down with a variable speed controller, but to speed the pump up is always very tricky or not possible. So we see that a lot of pools has circulation pumps that are too small to do a good backwash. And if you don't do a good backwash in your pool, then you know you get trouble with your water quality.
So
So
I guess it depends, and also, Gerben, on the type of filter that you have. But
yeah,
because some filters don't require as much backwashing because they're more like an absorption media, and other filters, of course, they do require a significant amount
yeah,
of backwash. Or
yeah.
if they're air assisted, then less water, certainly significantly less water. But I guess those are all considerations, yes, that you would look at.
So you have to look at the flow. You have to keep in mind the maximum head of the pump. So how much pressure does it give? And it needs to be a pump that is suitable for swimming pool water. So it needs to be um, consistent for chlorinated water.
Yes.
The
And
impeller can handle that
Yeah.
chlorination system. Yeah.
Yeah.
Kevin, if I can ask, so how many turnovers minimum is a requirement? Like I know there's some regulations about that here too, Scott. Yes, is it minimum 4 turnovers per
Well,
day?
it depends on where you live. In Ontario, where
Yes,
we're coming from, the turnover rate for a new pool now is six.
six.
Six
Okay.
turnovers a day, but most of North America is required 4 turnovers.
Yes, Kevin. And what's that like in Europe?
Well, it's a little difficult because since January this year we have a new legislation in Holland, um,
Yes.
um, and but we always had a turnover of three, depends on the
Hmm.
depth of a pool. So that means every 3 hours the pool water needs to be
Turned over.
it needs to be turned over to the filter system.
Wow.
But
So
for small pools and whirlpools, we have 10 minutes.
oh wow. So we
Every
would
10 minutes.
we would call that 8 turnovers, right? Every three
Well,
hours. Eight.
6 10 hours. Every 10 minutes.
Wow.
Yeah.
And
Yeah. No.
wow.
In a whirlpool, he's talking about, Scott. It would be every
Yeah,
10 minutes.
10 minutes for a spa,
Yeah.
where we use 30 minutes as our standard for spas and
And a, and
smaller pool systems. Yeah,
and
that's
a small pool, a children pool, needs to be has a turnover of 1 hour at least. But it's that's you have two rules, or we had two rules actually, because the turnover rules are not there anymore at the moment, because the new legislation tells you to have a look at the water quality, and we have
Yeah.
some extra parameters are introduced, and that's what now important.
I see.
It's
So
more you have to get there, and how you
yeah,
get there. The
they don't
legislation how
care
to
about
get
it.
there
Right. Right.
is not so important anymore.
But I mean, that in and of itself is a much more stringent rule. So whatever the former turnover rules were, you're going to have to do at least those to
Yes.
achieve the water quality results that the regulations now stipulate. So
Yeah.
Scott, it's like having an outcome-based regulation that says, this is how much disinfection byproducts you can have. This is how much combined chlorine. This is how much, whatever microbiology. So, go at it and make sure that you achieve those results, because they're going to be monitored on a monthly basis. And if you don't achieve those results, then you need to change your process
much
to make sure that it
much
does.
stronger legislation, which I like that. Right, like this is where you need to be. Get there.
Right,
However you need to get there, you get there, and
right, right. And so,
it makes a
Kevin, I
lot
guess,
of sense.
yeah, and Kevin, that means that those turnover rates that you mentioned are a minimum requirement. I would say that
Yes,
hasn't changed.
for
Yes.
sure. Yeah.
Okay, I see. So then,
Because if you don't use those turnovers, you're sure that your water quality is not okay.
it's not going to
Wow.
manage. Yeah. Okay, fair enough.
Switching gears a little bit, Gerben. So you're talked about this is the circ pump and the big turnover, the big
Yeah.
main pump, the heartbeat is what I usually say, and I think you said almost the same words. So now we're talking dosage pumps,
Right.
Mhm.
and what is the normal type of dosing pump you would use? Do you use peristaltic or what kind of pump systems
What
do
kind of
you?
pumps exist?
We,
Maybe. Yeah.
we
What
are
are
we are the manufacturer of peristaltic pumps, so we built our own dosing pumps. We built peristaltic pumps, but you also see some diaphragm pumps. So that pump has membrane pumps actually. So that's another kind of pump. It has another principle of working. They can build a lot of pressure. That's enough advantage. But the problem in swimming pools is that we also have to dose chlorine, and chlorine has the problem that when it's not when it's standing still in the lines, then you get some small air bubbles, and membrane pumps don't like air. So a lot of pumps has a de-air valve and has to be de-aired, and that's the problem.
Oh, and an off
Mainly
gas, yeah,
for
an off
small
gas valve.
pools like
Right.
whirlpools, or because you're using very less chlorine, then you have that problem with air bubbles in the lines.
So you have a diaphragm pump versus a peristaltic pump. So can you maybe give our listeners then a very, like a broad overview, the types of peristaltic pumps, the types of diaphragm pumps, and kind of like you've already touched on the main difference between the
Yeah.
two, but there are other aspects as well, right? And the types of
Yeah.
membrane pumps and the types of peristaltic pumps.
Yeah.
So could you
So,
start
so,
there?
so membrane pumps, you have magnet-driven pumps. So that means that the membrane that moves in the pump, it's like a small valve that's going up and down. So that can be done by a magnet. So every time you put the power on the magnet, you make one stroke, and then that's a little bit of dosing. But you also have pumps that has a motor inside, so then it runs constantly. That's most of the time for big membrane pumps. They
Right.
have a motor, and sometimes you can control the speed of the motor. The magnet-driven pumps, you can control them by impulses. So every impulse is one stroke of the pump.
Yeah.
And sometimes there is a pulse divider, so you on the pump, so you can, or a pulse multiplier, so you can say one pulse and the pump make two strokes, or two pulses and the pump makes one stroke. And what you can do, you can you can adjust the length of the stroke. So that's why for every stroke you can adjust the amount of chlorine or acid that's dosed at that moment.
Okay.
Um,
And then the peristaltic is
the
kind of
peristaltic pumps, it's a pump with a tube in it, and actually what you do is making a peristaltic movement in the tube. So it's like pressing down the tube, and then you moving forward the liquid in the tube. And the main advantage is there's no liquid in the pump itself; it's only in the tube. And there are two major differences with membrane pumps. Is that a peristaltic pump can pump air; it's no problem; it moves air,
right.
but it cannot make so much pressure like a membrane pump,
I see.
because a membrane pump is always making a stroke, and then a peristaltic pump is pressing down the tube what's in the pump. And if you press it too hard, the problem is that the tube will break.
I see.
So that's what you have to keep in mind with the peristaltic pump.
So I think our business, and I'm just overarching, Gerben, has most installations now would be peristaltic here, is what I think would be a fairly
I
normal
think so.
statement. That you'll still see other pump systems. So when you say pressure, like, do you see pools getting that much pressure? Like, let's say it was a 50 meter and it was 5 meters below deck. That kind of pressure, is that like? Can you explain when you say pressure? Where are
Well,
you picking up the pressure?
the peristaltic pump mostly can do 2 till 4 bar of pressure. A membrane pump can do 10 bar or more. So if you have a lot of back pressure in your system, like say 1 bar or 2 bars, or you have to inject for example, a slide, and the water has to be pumped up to 10 meters, then you have some extra pressure, and you have to keep that in mind. What's also important is to use the right injection valve, because your injection valve also determines how much pressure you need.
Hmm. I guess I
I have a small
wonder.
example if you want to see
Yeah,
it.
let's have a look in a minute. I
Yeah,
like that. But just to briefly, Scott, in municipal applications where you've got these large distribution lines under significant pressure,
right. In
diaphragm
water systems.
yes, in water
Water lines.
systems for drinking water,
Right.
diaphragm pumps are kind of the norm. That's where they're
Okay.
used.
Yeah.
In pools, peristaltic pumps hold a lot of promise because they're typically, except for those areas that Gerben has just pointed out, where there might be some more pressure. But in pools, generally, Gerben, it's a lower pressure environment, right?
Yeah.
Right.
That's what I'm kind of getting to. It's certainly I think one peristaltic are one because they're cheaper, and two, we don't normally have those high pressure systems, and that's why I'm
Well,
kind of trying to focus on that. Where would you see that? Unless it was a very large system, I've been in 50-meter pools. The filter system might be 5 meters or even more below grade.
Yeah.
So is that the kind of pressure we're dealing with, or was it louder? Because usually we're having chemicals on the return valve, so
Yeah.
the pressure isn't really there because you have a.
Well, there's another aspect is that if you look at the injection valves, I have one here. Chlorine has a very bad habit is that it sticks to the end of the um, injection valve. So
Right.
you get some crystals and it will block the injection valve. And when you have a membrane pump that makes a lot of pressure, then sometimes those crystals will be pushed away. But with a peristaltic pump, because of you cannot do so much pressure, if there is a blockage, you will have more. You have to take effort to clean it.
So could I just give you a hypothesis here? So if we a lot of where people have problems with this, and they have their chlorine system a long way away from their injection because of the design of the pool,
Mhm.
and so they're constantly getting blocked. Would you
Yeah.
maybe say that's a great application to use a diaphragm pump rather than a?
No, it's from my perspective, it's if you're using a peristaltic pump, if you have a very long line, you have some loss of pressure. So you need a pump that can do enough pressure.
Yes.
But you can also have some tools or tricks to avoid
Overcome. Yeah.
to avoid the blockage of the injection valves.
And you talk about your injection quill, like that's an
Yeah,
important piece of equipment that can actually overcome that problem, Kevin. Is that what you were talking
yeah.
about?
Our injection quills. You see this top is made of Teflon, and chlorine crystals won't have a good grip on it, so they don't stick on it. And we also have a special backflow system because there's a small rubber ring here, and that will go open when you put some pressure on it. So this valve is opening at zero point 0.5, so half bar. And a lot of injection quills have a backflow protection that takes 1.5 bar to open the valve. So that's 1 bar more than our valve. So that's why we always use this valve at our pumps, because we know we have a good backflow protection,
And
and we
it's not
don't
going
need
to block
no, and we don't. It's not gonna clog, and it's don't need so much uh,
pressure.
pressure to open.
Yeah.
and
I
and
see.
less maintenance, and it's that is a very common issue in swimming pools, is that blockage. And I
Yeah.
was just and why I'm kind of getting to this, Gerben, I was just at a pool, I don't know, a month ago, and they, from the chlorine tank to the injection is 250 feet,
Oh boy.
Okay.
and that's what they deal with and have for many years. And so that,
You may be able to help them, Scott.
yeah, it's a constant. So I've just kind of,
Yeah.
these are things that we run into.
For
So
Yeah.
sure.
how
For
do you
sure.
help
Oh,
them?
that's
I'm
practice.
exploring my own ideas while we're
Yeah.
chatting.
Oh, that's
No
okay.
problem.
That's
No
good. That's
problem.
why we're talking. That's okay. So, Scherben, maybe then broaden the scope a little bit. So, what then makes a reliable pump? And so, let's maybe put aside the diaphragm pump, because except in exceptional circumstances where we do require this higher pressure, it's not really necessary. But there's still lots of difference between one peristaltic pump versus another, right? So,
Also, you have peristaltic pumps. The tube in the pump is very important. So the material of the tube is important. Um, the material we use is marprene, and that's a material that's suitable for acids and for chlorine. but you also have tubes from PVC or neoprene. But those materials are not suitable for chlorine, or only for acid, but not for chlorine. And then you get a problem if you try to pump those liquids. Your tube will be damaged, and you get leakages.
I see.
And also,
Gerben, can you say the first word? Is that a?
Gerben, the material of the tube that you're
the
using.
tube, yeah, we always use marprene, but marprene, it's a bioprene prene. That's a kind of rubber that's suitable
It's a
for
special material.
mechanical stress, and also very good to chemical for mechanical stress, and good for chemical applications. So like for
And
acids and for
Chlorine.
chlorine,
so
This is
they're a little
oxidating,
Yeah.
yeah.
Oxidizers. Yeah, that's it.
oxidizers. Yeah.
That's it. So that's important, Gerben. So the tube's important, but then also, the way that the pump functions, right? So you briefly touched on proportional dosing, and maybe now is a good time to kind of get
Yeah,
into
well,
that.
we can,
What
we
what
can.
is that all about? Like, how is that differ from the on-off, and why is this so important? Let's talk about that.
So an on-off dosing will give you like waves of chlorine through the pool. So your chlorine value will go up and down, up and down. Every time you have your pump on, the chlorine level goes up, and when the pump stops, your chlorine level goes down. And with a proportional dosing, so the P function means that your pump speed is controlled on the basis of the deviation of your set point, so your wanted value, your set value in the pool, and the measured value in the pool. So if you have a set value of 1 milligram a liter, then the pump will run on low speed when you have a small deviation, and when the deviation is bigger, then your pump will run on a higher speed. And that way you get a flat line in your pool.
But some peristaltic pumps are not capable of doing that at all, right? So the
No.
ones that I see a lot in pools, and Scott, maybe you can confirm or deny if you like. But the ones that at least that I've seen at pools here, most of them are on and off pumps.
Yeah,
Yes.
because that's dependent of the construction of the pump. What kind of motor is used? Is that motor is it possible to control the speed of the motor? And if it's not, then you have a fixed speed pump, and that can only runs on and off.
Yeah.
Right.
And
So the problem that we get into is that the owner doesn't ask for that. The pump is cheaper to put on, like it gets back to right. So it's design criteria that's put in with the understanding that ultimately you want a consistent disinfection system, not this meets the criteria of minimum standard. And you're talking about a different level of understanding, quite frankly, that is not, even though if it may be understood by folks, they don't put that out. And then the owner, the operator, is constantly fighting a battle. And because we have wider parameters for pH and chlorine allowances here in North America as a general rule,
There's no
Gerben,
push. Right.
people are constantly fighting it. And it just,
Mhm.
the knowledge that what we're doing today is filling in some gaps of what people deal with all the time.
Right.
And don't know why, right?
Yeah.
And they're going, well, this is what I was given, so if I give you this car, this is what you have to drive, and you have to understand what the value of a better equipment is.
It's good to hear. It's actually it's the same what we had in 20 years ago. The heating system in houses here were also very easy. When the temperature was too low, the heating was on, and when the temperature was okay, the heating goes off. And that means that your temperature in your room was between, for example, 18 and 21 degree if you put it on 20. But now with all the proportional controlled heaters, it means that your temperature is more stable and the use of energy is less. And that's what you see when you have an on-off dosing. The use of chemicals is mostly more than when you have a proportional controlled dosing pump.
Yeah.
You
There's a
took the
cost.
words right out of my mind because I just moved into a house and it has a multi-stage furnace system, and the difference you hear it coming on It's a great analogy.
Yeah,
Great
it is
analogy.
a good comparison for sure. And I was going to say that there's an immediate cost benefit and a very compelling, payback
Yeah.
for using a proportional dosing pump for
Yeah.
lots of different reasons. And anyway, which we can get into. But maybe then, Kevin, maybe we can shift a little bit now because obviously, as you did your overview at the Better Pools conference, talking about the different monitoring systems, the other challenge that we've come across a lot, and I know Scott has too, is where the on-off pump is basically increasing your chlorine level, but it always overshoots. And the challenge is that if you have a control system or a monitoring system that is reactionary, like an ORP system, that it won't actually tell the pump to shut off until you've way overshot your target, because you don't get to hear about it until half an hour after you've actually achieved your target. So the pump's been running significantly longer for a longer period of time. So maybe talk to us about kind of how a pump can play such an important role in combination with kind of the monitoring and the control side of things. So how does it play a role in an automatic system from your perspective?
Well, if the pump and the control systems needs to be compatible with each other. So if you have a controller that can controls proportional, then your pump needs to be proportional controllable as well.
Right.
Because if you have an on-off controller, you cannot control a proportional pump. So, and if you have a proportional pump but your controller is on-off, it doesn't work either.
Yes.
So that's why you have to be sure that your controller and your pump are
Aligned.
aligned for each other. Yeah, that's the right word what I was searching for.
Yeah.
And another thing is important is the capacity of your dosing pump, because if you have a dosing pump with too much capacity, then you get overshoot as well.
Okay.
And most of the time people think, okay, I get a pump that's big enough and take one size bigger, then I'm sure that I always have enough chlorine in the pool. But if you always have too much chlorine in the pool, that means that you and I know in Canada you can have more chlorine in the pool as here in Holland, because since this year the maximum ppm value of chlorine is 1.5 for indoor pools. So if we have
spas, Kevin, and the maximum for spas is 5, or what is it?
no, it's in Belgium it's 3 milligram a liter, and in Holland since this year all indoor pools needs to be at 1.5 maximum.
Also spas?
Yes.
Oh, wow.
Also, no
Wow.
exceptions. Yeah.
Wow.
Okay. Wow, that's a very different.
So you need a good control system, and it's not only the dosing pump that's important, but it's also important to be sure you get your sample water. But that's also a pump. You need a sample water pump that it's fast enough to your controller, because if it takes 2 minutes from your water to get from the pool to your controller, that means that you're always 2 minutes
late
behind schedule, 2 minutes late. So that's why for monitoring system, the rules is that your water is there and it needs to be there in 2 minutes maximum.
Maximum 2 minutes. So I was going to ask you about that. So if you're using, and we'll talk about that a little bit more, but so you need to make sure that your sample water is there under 2 minutes, basically.
Yeah.
Okay. Because that has a big impact as well. I was going to say
1 minute.
Yes, 1 minute. Okay. Because that, if you want to have really tight process control, not only do you have to have a sensor, I guess, or monitoring tools that can measure the free chlorine right now at this moment in the pool, or the water coming back from the pool. You need to know it now, not in half an hour, what it was half an hour ago. You need to know now, but you also need to make sure that your sample water gets there quick enough so that when you're then doing your dosing, it's going to be almost instantaneous, right? It's very responsive to the current situation and trying to manage that current situation. So how's that going in Holland with the new regulations? How is that working?
How is it working? Yeah, the pump needs to be adjusted to the pool, and your controlling parameters like your A factor and the amount of pulses that you send to the pump. Mostly, the most controllers work with pulses, so 0 to 100 pulses, and 0 pulses means no dosing, 50 pulses means 50% dosing, and 100 pulses a minute means 100% dosing.
Yes.
That's the way how pumps are controlled. Sometimes they will be controlled by 4 to 20 milliamps, but pulses is the most common way to control the pump. And that means that you have to look at the capacity of the pump, and with our our pumps, you can adjust the tube what's in the pump, so you can play with the capacity of the pump. So the pump is in speed, you can control it in speed 0 to 100%, but you can also play with the diameter of the peristaltic pump, so of the tube size. So the bigger the tube, the bigger the pump capacity. But
so that's a predetermined. You're gonna because we have multiple size for very peristaltic as well. So you'll have the opportunity to put a smaller, let's say a smaller pool system. You can put a smaller feed tube in. So you can't modulate that. You modulate the cycle, but
it's both.
Predetermine that
it's both, as I understand it correctly, Gerben. So the size of the tube determines how much liquid you move, as well as the speed. The ratio in
the
which
variable speed.
Right.
Variable speed of the pump, yeah.
Wow, that's
because the pump is running around, so the speed is dependent for how much you will pump, and also the diameter of the tube.
Wow, that's really getting tight parameters.
I can show you if you want.
Is that DIN standards that we're dealing with, Gerben?
What do you say?
Is that DIN standards, or are they Holland?
No, that's Holland standards. We don't have DIN standards. That's for Germany.
You're German is DIN. You're Holland standards. Okay.
Holland is kind of leading the way in terms of regulations. And Belgium both have probably among the strictest regulations in the European Union. And typically, other jurisdictions kind of follow suit down the line too. Gerben, you maybe have some things that you could potentially show us as well, just to give us.
I can show you a pump head from our pump with a tube. I can grab one. I will.
Okay. That'd be great.
I can take it here. This is a pump, and we can take off our pump head. I will bring it to the camera. So this is the tube I mentioned, and this is marprene. That's the material of the pump, of the pump tube. And you see the tube is, this is one of the rollers, and these are rotating like this way. And by rotating, the tube will be pressed to the top, to here. So when you close the pump head, you see the tube will be, when I put it in on the right way, the tube will be pressed together by the roller and the top of the pump head. And you see that's the way how it works. So you close it. And with this tube, with this pump head, is the easy load pump head. You can easy move your tube a little bit, but because if you can imagine that if the pump is rotating for a few weeks, the tube will be a little flattened by the rollers, and then the pressure will be less from the pump. So we always say you have to move the tube 4 times a year. And with our pumps, you don't need to take off the whole tube and make new connections. No, we have the connections on the end of this tube, and it's 1 meter of tube, and you can move it a little bit, and then you have a fresh piece of tube in your pump head.
Very easy, yes.
You don't have to. Some pumps needs a segment of tube, what you have to take out of the pump, but then you also have to release the pressure side and the suction side of the pump, and the suction line and the pressure line.
Right.
And that means you get some chlorine on your hands, or you need gloves, and if you get it on your clothes, you know chlorine and clothes is not the best combination, because you get some white stains on it, or when you use acid, you get some holes in your clothes if you don't don't keep an eye
Gives
on
are
it.
really cool jeans these days, though, Gerben.
Yeah.
Yeah.
Now you know how
Pay
these
extra.
will be made.
Pay extra.
Cheaper way to do
I
that.
like that feed tube because normally our systems are screwed in. So you take
Yeah,
a screwed in
you
head
have a
off,
segment with
throw
two
it out.
connections, and yeah,
Yeah,
that's what
and
you basically
that's
see.
the normal pump system that peristaltic system that you would see, kind of the standard look. Um, I haven't
Yeah.
seen any like that are actually move the tube to my knowledge. But that's an interesting perspective for sure.
So,
Yeah.
Kevin, maybe then talking about maintenance and preventative maintenance, like it doesn't seem that there's a lot. Like a peristaltic pump seems to be a lower maintenance pump then in that way too. Is that true?
Well, if you look at the peristaltic pump, you need to change the tube for in our case every year, once a year, and you have to move it a little bit. Some other manufacturers they advise you to change your segment of tube every 6 months. A membrane pump has a membrane inside, and if you get a crack in your membrane, you don't get pressure anymore. So you have to change your membrane as well. And some manufacturers have a counter inside, and they tell you, okay, after 1 million strokes or something like that, you have to change the membrane. But then you have to open the pump and take the whole pump. Um, um, yeah,
Head
you
apart. Yes.
take it apart to remove your old membrane and put in a new membrane. And well, the cost of a membrane is I think higher than a tube.
Yeah.
And then you have also take in account the time that you have to work on it. So you see how fast I move over the tube. So once a year you have to change it. That's maybe 10 minutes work.
Right.
To take off a membrane and put it back, it's mostly more time.
And I
And also,
imagine, I
and
suppose, yeah, go ahead. Sorry.
yeah, and also that pump has has some chemicals inside. So when you open it, it's not the nicest job to do.
Yeah, that was my question.
I
Yes.
would say yeah, and for many locations, let's say a hotel or something like that, just use as an example, the staff aren't really either capable or supposed to be taking pumps and motors apart, so that becomes a challenge. So they understanding who's going to be doing the maintenance on your system is got to be part of the knowledge base.
Yeah.
Yeah,
Yeah, but I suppose then also because you mentioned peristaltic pumps, of course, don't have the water doesn't go through the pump; it actually just goes through the tube. So in that way, I guess it's a more robust pump, right? Like in comparison to another type of pump.
yeah. If you compare with membrane pumps, you also have a few advantages because a membrane pump needs backflow prevention. A membrane pump can how do you say hevelen if the pump is at a higher level than the pool. That means that your chlorine tank can be emptied by gravity to the pool. Um, uh, with a pump like ours, you don't have that problem. As long as the pump head is closed and the rollers are on the tube, you don't have a peristaltic pump cannot. It has when the pump head is closed, then you have there's no
Siphon. You can't have
possibility.
siphoning.
No,
Siphoning.
no siphoning. No, that's the word I was looking for. Yeah.
Yeah. Yeah.
Good. That's excellent. Yeah. So maybe we haven't talked a lot about automation, and obviously the regulations in the Netherlands now are very strict and difficult in some ways. I'm sure it's not been easy for pool operators to operate within such a tight range for
Mhm.
chlorine and pH. So how does this fit into kind of automation? So pool automation, obviously you've explained a little bit already
Yeah.
what's necessary to get that proper ratio with pumps. So can you tell us a little bit more about what does that look like and how can that potentially be beneficial for a pool facility?
Well, the main important thing is that you put your set points, so your wanted values, on the right level. What I sometimes see is that people do a measurement and they say, okay, the chlorine value in the pump in the pool is too low. I moved my set point a little higher. But I always say, just see if your calibration is okay because your measurement is the first thing that has to be okay before you can do a good regulation. If your measurement is off for one point, that means the chlorine level in the pool is 2 milligram, and on your display you see 1 milligram. Yeah, then it's very hard to have a good control system. So
Yes.
your input needs to be okay. So your measurement needs to be okay. So you have to check your sensors. You have to calibrate your sensor. You have to calibrate your pH probe on a regular basis.
Yeah.
But some people say, okay, I do that once a year. Well, I don't think that you can work with a situation like that. I think you have to check it every week. And when the deviation is too big, you have to do a calibration of your chlorine
Right.
and pH sensor.
So let's say you have all of that, and maybe you can walk the listeners through what's been happening or what's been allowed to happen, I guess, in terms of having automated monitoring. So
Well,
if you have that capability, so what are the requirements? Because obviously, this is, I think, an opportunity to support a very overworked operational team, people that are really, really busy trying to do a million
mhm.
things. So if that could be automated, like what does that look like? Explain to the listeners what you guys have been working on
Well,
at local pool there, a very large pool complex there, and
yeah.
then what is the benefit for a pool operator or for a pool owner
Well,
to automate?
if you have an automated monitoring system, that means that your manual checks of the pool um, don't have to be done. Normally, you have to do it twice a day, and with a good working monitoring system, you only have to do a manual check when your monitoring system is off. Well, the big advantage is you don't need some people who take the samples from the pool, who grab the samples, who analyze the samples. So it will save on time of people. On the other hand, uh, when you have an automated system, somebody has to have a look on it. So that means if there is an alarm, uh, well, what we see is that the system is coupled to a building management system, and that means that one of the operators will get an alarm on his phone or a red light somewhere if there is an alarm and one of the pools doesn't has the right values.
Right.
What we see is that's one of the most difficult points, because when you have somebody who do a manual measurement, he sees, okay, the measurement is okay or it's not okay, and when it's not okay, he has to take action. He
Yeah.
has to he has to close the pool, or he have to uh,
Do
call.
immediate steps. Yes. Fix the
You
problem.
need to fix the problem. And with an automated system is an advantage that your measurements are always done on the same way. But when there is a problem, you need to be sure that somebody
Somebody's
gets an alarm,
responding.
that
Right.
somebody has an eye on it. And what we sometimes see is that the email wasn't working, and then you didn't get an alarm message, or something else is going wrong. And the problem is also that if there's nobody who's doing manual checks, people, if they don't have to do it, then when there is a problem, they don't know how to do it anymore, because they didn't do it every day, and now they have to do it again, and they forgot how to do a manual reading, and that's also a problem. But
But
the biggest advantage is that people don't have to take samples twice
Throughout
a day.
the day, and that you have inconsistency because different people,
Yeah,
different methods, different
yeah,
measurements. It's
yeah,
all the same because you have reliable pumps, reliable sensors that can accurately and precisely measure.
yeah,
But
for
the
sure.
challenge, and I think Scott, yeah, go ahead, Scott. The challenge is still there to make sure that somebody responds
yeah,
when there's an alarm.
right.
Yeah.
It's the instrumentation has got to be one excellent, and then two, staff kind of the term I would use there is learned helplessness. I've never had to do this, so I don't know how to do it. Um, However, though, for private facilities that don't have the technical ability to have somebody who is like a
There all the time.
right, you can have somebody, a service company or something, have that reactionary if you can set that up. And 99% of the time everything's great, and periodically somebody's got to check in.
Yeah.
remote monitoring. I used to do SCADA with, if you know what SCADA is, and I know it's been overtaken by other options now, but when that came in, it was like, oh wow. But now it's just normal, right?
Yeah.
Yeah.
So in the
Yeah.
water and wastewater business, that kind of remote monitoring
Yeah.
and and fine value is just normal. And now we're trying to bring it to swimming pools. I love it. I love
Yeah.
it.
Yeah.
Yeah.
But I think maybe, it's good advice, Gerben, to consider, okay, you need all those things in place. Like Scott says, it has to be a precise, accurate system. It has to have
Yeah.
the right tools. And then secondly, you need to have the preventative maintenance. Somebody still needs to go and verify the system once in a while.
Yes.
And you need the correct response if there is an alarm, so that, things can be fixed, right?
Yeah, the system needs maintenance as well. It has to be calibrated as well. So you have to do a check every. Yeah, I think normally it's at least once in a month, and yeah,
But
what you see.
that's a big cost savings and a big, resource savings. Like a check once in a month is very different from the
Three
kind of
times a
time,
day.
yeah, the kind of time that people are spending right now, right? So that's where
Well,
the opportunity certainly comes in. And then, for future, kind of a future, and maybe not too distant future, that you have some smart tools that can also have a kind of a correction capability, right? So I know that you don't just have the monitoring system, you have the control side as well. And so maybe, some ways in which there can be some additional eyes and ears, that preventatively or predictively can see when
predictive.
something may
Yeah.
go wrong, right? So having the data science piece on the side as well, I think, is very
Yeah.
helpful, because all of that together manages the risk in a slightly more proactive way too. So
Gerben, just to kind of round this out, and I think you may have touched on most of it, but so from a PM preventative maintenance perspective and making sure this goes long term, not just stick it in and away it goes. Uh, just a couple quick tips on preventative maintenance. If you set a system up, or when you set a system up like that, what would you tell the customer? Real quick, succinct ideas.
Well, the customer has to look, if you look at the control system, not only the dosing pump. If you look at the control system and the dosing pump, people have to look if there is any debris in your filter, because there's a pre-filter that takes out all the dirt that's going into your measurement system. You don't want that, because that will give problems to your measurements. It's depending on what kind of measurement it is, but you have to check regularly if your values are still in line with your manual measured values. So you have to, when you do your measurement value, your manual measurement, just check the display of your control system as well, and are those values in line or not. And then you have to check your dosing pumps. If is your container with chlorine still full? Is your pump reacting on the control unit? And are your injection quill still open and not blocked?
All right.
good
That's
tips.
a quick check
Uh,
for every day.
and I'm just gonna switch gears here. So we have so many pools are in action, and I got this pump put in, and it's an on off, right? It turns on when the controller asks for it, and it
Yeah,
shuts off
yeah.
when it doesn't need anymore. And you might have this going on, but what? How can I better manage that if buying a new pump isn't always an option? Correct.
Well,
Right?
sometimes you have the possibility with your controller that you can change the interval time of the pump. So you have an impulse length controlling system. That means that your pump is going on and off, but it's, for example, you have a period of 1 minute, and you could say in the 1 minute the pump is running 30 seconds, and then it's 30 seconds off. That means that the pump is running on 50% of the time. But you can also say it's running for 6 seconds, and then 45 seconds off. That means that the pump is running at 10%. So you can change the pump is then only on or off. You cannot control the speed of the pump, but you can play with the length that the pump is running in a certain time, and that can help you as well.
So smaller amounts over more often.
Yeah, but that
Shorter cycles more often.
but that means that your controller needs to
Have the capacity to.
have that possibility. So that's not always
It's not just the
the
pump, but
case.
also the controller. Yeah, to
Yeah,
see if the
yeah,
controller can
It's
manage
it's
that.
holistic. Would that be the correct
yeah,
term? Els and
Yeah,
Gerben, just they relate. They talk to each
they
other.
do. They do. They
yeah,
are intrinsically connected, and that's important. That, like Gerben said, that they're aligned. So whatever can be done to get the maximum out of your controller and
yeah,
get the best possible flexibility within your existing infrastructure. And we've worked
yeah,
with a few clients to help them, and it gets you to a certain level that's better, certainly than where you were. But there is, of course, a case to be made that a pump is a relatively small investment in comparison to, and even the
yeah,
controller, the combination is a relatively small investment in the context of all the capital that you might be able to acquire in a swimming pool, but it has the potential to have such a powerful return on investment
Right.
as well.
And the offshoot of that, better water quality, better air quality, better HVAC.
Everything.
The
Yeah.
things we talk about all the time.
Yep.
yeah.
Uh, I don't know if anybody's hearing it, but we're trying. Gerben, as we kind of wind down, have you had any walk? I've walked into some crazy systems. Can you let us know something like where you walked in and gone like, wow, what's going on?
Well, I saw many strange things. I like a pump that is pumping the wrong direction. So you're not pumping your chlorine from the tank to the pool, but from you're pumping pool water to your tank
Oh my
because
God.
somebody put in the tube of the pump and in the wrong direction. That's what we see. Well, quite often, more than once a year, I think. Uh,
Wow. That's
well, yeah.
crazy. Hit.
I saw
Wow.
many strange things like pumps with a lot of unsafe situations, like pumps that are leaking or dripping, or pumps that are set to manual because
Okay.
the safety the safety was not okay. For example, the power plug, the power of the pump is switched off because there was no flow in the system, and somebody thinks, okay, take away the power plug and put it in a wall socket where I have some power, then the pump will run. But if there's no flow in your system, you don't want your dosing pumps to run because maybe you can get some acid and chlorine together,
Yes.
Right.
and
Usually
that's not
that's we see that in the paper and they say gas bubble in local pool. Somebody's
yeah,
flipped the pump, taken the dosage feeder and put it into a plug that's
yeah.
not on off, right? And that's
And
just a
Kevin,
safety issue.
you've had like situations where the chlorine level has been really high in the pool, then I guess, when that happens.
Yeah, that's what we also sometimes see is that people put the pump on manual mode because they change the barrel and they want to take off all the air bubbles. Then they get a phone call and they forget the pump is on manual mode, so the pump is running on all night. And next day there are some swimming lessons and the chlorine level is 20 or 30 milligram a liter.
Wow.
Oh
Yeah.
boy.
And it just happens.
And it just happens.
Yeah.
It's more than once a year.
So that's why good monitoring systems with alarm capabilities are absolutely critical so that they can warn you that something is really
Yeah,
wrong, right? Or digital
sure.
tools that can
Sure.
track this.
Yeah.
Yeah, I hear you. Okay. Very,
I
very interesting.
I think it's phenomenal, and I think we probably need to wind this down, Els and Gerben. So I think we'll come to an end of our talk. And what a awesome, for me as a pool person, love the conversation. It's so helpful and interesting.
Yeah.
The importance of that reliability of the pump, how they're connected to process. Uh, and hopefully helping people not only understand where they are now, but how to move forward. And that's really what
Yeah.
we're thinking about: where we are, how do we move forward and make it really reliable, cost effective, and understood. And
I
thank you
hope
so
to
much.
I hope that I helped you moving forward in in this with this conversation.
Yeah.
That's excellent. And enjoy your vacation, sir. I think it's probably well earned.
Yeah.
Thank you.
Kevin, thank you so much. Yeah, I want to add my thanks to Scott's. I think people
Okay.
find this very interesting and useful.
Yeah.
we'll just sign off now. But thanks so much for making the time for us today, and we'll connect when you get back. Have a great
Okay.
holiday. Thanks so
No
much.
problem.
Take
Thank
care.
you.